What we're looking at the moment is hypothesis testing. We've only introduced it in very vague terms, and at the moment we are only interested in doing hypothesis tests on continuous variables. We'll look at discrete variables in the chapter that comes after this. So let's just look at the first example. I haven't really taught you how to do it yet. I thought the easiest way of doing it would be by going through some examples. This could be preceded by: the great God of statistics has told us that students joining Year 7 have weights that are normally distributed, mean of 70, variance 7.5 squared. A random sample of 90 students from the latest intake has a mean of 71.6 kilograms. Is there evidence at the 5% significance level that the mean weight of the new intake is more than 70 kilograms? Right. Let's just talk about what the question is going on about. The information up here, it is known that students joining Year 7 have weights that are normally distributed like this. This, presumably, from the context of the question, is about all Year 7 that we know about, apart from this group of Year 7. So that may be based on previous research. Okay, and this is given to you as they are distributed like that. It's one of these: the great God of statistics has told you that, to make the question doable for you. Okay. Then somebody in the school has looked at this new intake of Year 7. They've looked at 90 students and they have weighed them, and they have got the mean weight to be 71.6. What they are saying is that acceptable compared with this information here, or are this lot a bit weird and extra heavy or something? Okay, or do we have an obese weight year group? Well, I don't know, I have no idea. Would this make more sense if we change the year group to Year 12 or something, or Year 20 or something else then? I only know my weight in stones. It's kilogram stuff. Yeah. No idea why I'm in kilograms. Anyway, let's just go through the steps, and what I'm looking for now is my bit of paper with the red pointers on. This is what we had last lesson, okay, and we're going to work through here. Step 1, we're going to define the null and alternative hypothesis and make a note whether the alternative hypothesis is one or two-tailed. Right, what does that mean? First of all, the null hypothesis. From those of you who were here last lesson, what notation did I use for the null hypothesis? H with a little zero, yeah, H naught as we normally call it, yeah. H naught is everything's okay, nothing's changed, the world is wonderful, nothing's changed. So H naught will be that the mean weight of the new intake is 70 kilograms, because that's what it's always been. Nothing has changed. That's what it is in words. And in symbols, we would write down for that for the new intake, mu equals 70. And then the alternative hypothesis, and what notation do we use for the alternative hypothesis? H1, that's right. Now, it says here, is there evidence at the 5% level that the mean weight of the intake is more than 70 grams? So H1 is the mean weight of new intake is greater than 70 kilograms. Or in other words, mu is greater than 70. Now, this bit here, in fact that sign there, tells us whether we are dealing with a one or a two-tailed test. We are only interested in a deviation one way. It's a greater than. If it was a less than, it would be one way. What do you think it might be if it was a two-tailed test then? Between two, so going either side. And exactly what symbol do you think it might put? Not equal to, yeah. Anyway, this one here, that symbol, that tells us it's a one-tailed test, because we are only going in one direction. And we'd always usually write down at this point as well what the significance level is, 5%. So we're doing a 5% significance level. That's how you start laying out this question. Now, what I suggest we do is a little sketch of a normal distribution curve, and we do this sketch based upon H naught. So based upon H naught, the mean is 70. Standard deviation we usually write at the side of the curve is 7.5. Now what we are going to be interested in here, for a 5% test in a greater than, we want to look at this area over here, where the area in that shaded bit is 5%. And we are going to work out a value here, which we will call C, C being the critical value. And if the sample's weight, if the sample's mean is above that critical value, if the sample mean is in this region here, we're going to say, no, there's something different about these kids. What we will do is we will reject H0, which leads us to accepting H1, the alternative hypothesis. However, if the sample mean of our sample is in this region here, lower than that critical value, we'll say, yeah, we're quite happy to accept H0. There's nothing particularly unusual about their weight. So that's the process we're going through. So the crucial thing that we've got to do is to find the value of C, because we know the sample mean. So what we have got to do now is to find C, this critical value. So can anybody suggest how we would go about finding that C value? Yeah, because our tables are less than tables, so what we are looking for is an area over here of 0.95 for our critical value. And we are looking here at sample means. So I haven't labelled this x-axis, but this x-axis here is W bar, our sample means. And what is the distribution then of W bar? So let's hang on, let's just check this. W, first of all, is distributed normally, 70, 7.5 squared. That came from the question. So what is our distribution of W bar, sample means?
The mean is 70.
Yep. 7.5 squared over n. Sigma squared over n, and n was 90. So what I need to do now is I need to find C such that the probability W bar is less than C is 0.95. I want to find that C value according to that. So, how would I go about doing that? I could anti-phi. I'm going to do the phi bit first, but then I will anti-phi. Yeah. So I'm doing over here phi of C minus the mean over the standard deviation equals 0.95. That's how I do any less than probability. Then, as has been suggested, I will anti-phi. Now, anti-phiing 0.95, if you look at your green tables, down the bottom, you will find it there. You haven't got to keep working it out. I think we looked at this last time. If you look at your tables, 0.95, it's one of these arrow ones here, 1.645. You will use it a lot. It will just be in your head at some point, okay? So if I anti-phi 0.95, I get 1.645. So I get C minus 70 over 7.5 squared over 90 square rooted equals 1.645. Then I rearrange that to get what C is. So, is anybody getting a value for C from rearranging that? 71.3, I agree with. Okay? So, our C value on this diagram down here is 71.3. The sample mean that was given to us was 71.6, which is over here. 71.6 was our sample mean, which is in this tail over here. It's in the tail. There's less than a 5% chance of that happening if these kids were normal kids. And we said because the chance of this happening is less than 5%, because it's in the tail, we need to reject H0, because we have got a result which is less than 5% likely. 5% was our significance level. If you reject H0, you have got to accept H1, then you need to end your question with a sentence relating to the context of the question, and that would be that we conclude at the 5% significance level that these year 7 do not have mean weight of 70 kilograms. That's corresponding with our alternative hypothesis. So these do not come from the normal population. Something has changed in this cohort compared with that. So we say it's not a mean of 70, actually we can say it's a mean of greater than 70. That's what our alternative was, wasn't it? I'm going to change that. Now these year 7 have a mean of greater than. That's what I should have put down there. That's what our alternative hypothesis was. Okay?